Module 12 is about entropy for the property diagrams, in terms of property diagrams. So we have the same course outcome as the previous module, and for this learning outcome for this chapters, for this module, students should be able to explain, to calculate the entropy changes that take place during processes for pure substances, incompressible substance, and ideal gases using property diagrams. Okay, so for the contents, for the concept of entropy, we will cover about property diagrams which involve entropy, the TDS relation, Gibbs equation, the entropy change of solids and liquids, and the entropy change of ideal gases. Okay, so for the property diagrams involving entropy, so we have TS diagram here. So actually we have TS diagram here. Okay, this is the area. This is T from state 1 to 2. Okay, we have 1, 2, 2. This is actually number 2. Okay, TDS. The area is actually under the curve is actually T versus S. Under the curve is TDS equals to Q. Okay, so the heat, the heat is actually area under the curve of T versus ds. Okay, so the area under the process curve represents the heat transfer for internally reversible processes. Okay, this is TS diagram. So this one is H is the enthalpy versus entropy diagram. We call it as a Mollier diagram. So for the Mollier diagram, this is the delta S, this is delta H. Okay, for adiabatic steady flow devices, delta H is a measure of work. Okay, delta H is a measure of work, and delta S is a measure of irreversibilities. Okay, so this is the examples of TS and HS diagrams for water. Okay, so this is TS diagrams. Okay, saturated liquid line. We have pressure line in here. Okay, and we can actually find the data from this table, this diagram. But actually, we also have this has been represented in a properties table as well. This is Mollier diagram. Okay, Mollier diagram is a useful aid in solving steam power plant problems. So you can use this to estimate the value, find the data of the relationship between H and S at certain pressure, which connect at certain pressure and certain. This is the quality with different quality, and this is at certain temperature as well. Okay, so you can use this. So this is the activity number 1. So you can show the Carnot cycle on a TS diagram and indicate the areas that represent the heat supplied QH. It is so easy. So just draw TS diagram and remember about the Carnot cycle. Okay, so the diagram of a Carnot cycle, state number 1 to 2, 2 to 3, 3 to 4, 4 to 1. Okay, so on that, draw that diagram first and indicate the areas that represent the heat supply. Okay, so heat supply is the areas under the curve, right? Okay, so can you identify that and make sure that you need to label the QH, heat rejected QL, and the network output. So where can you get the network on this diagram? Okay, on the TS diagram, where is your work net out? Now, can you try this?